So we're going to look at some statistics, and we need to find the mean and the variance of some random variable x. Now all we know is that the probability density function, PDF, which is written here, follows this function here, f of x equals 4x cubed. And the support of this function is between 0 and 1. And it's a continuous function as well. So it's not 0 or 1, it's 0 and 1. It can take any value between there. Okay, so first of all, we might want to check that this function here is actually a valid PDF. Now, there's a way in which we can do that. So what we can do is we can take the integral from negative infinity to infinity of 4x cubed with respect to x. That's the general formula, but we're given that the support is from 0 to 1. So to rewrite this correctly, what we would say is from negative infinity to 0, 4x cubed dx, this will equal 0. Because if it's from 0 to 1, it's impossible to be in this value here from negative infinity to 0. And then also we've got from 1 to infinity, 4x cubed dx is also 0, because again, as it's between 0 and 1, there's going to be no values for our function to arrive in there. There's no probability values in there. So then that leaves us between 0 and 1. So now what we need to check out for is between 0 and 1 of 4x cubed dx, this equals 1. Now if that's the case, then we know that this is a valid PDF. So this is just the power rule, so we can go ahead and integrate this function, no problem. So 4x cubed, now that becomes x to the 4, with the 4 there will stay, that's the multiple. And now we divide by the new power, which is over 4, and that's integrated from 0 to 1. Okay, so now we just work out the values. So when x is 1, 4x to the 4 divided by 4 is 1. And then when x is 0, this term in here becomes 0. So then that equals 1. So therefore this is a valid PDF. So that's that checked. So now we can go on and we can try and calculate the mean, because now we're confident that it's a valid PDF. So let's go on to do that. So, sticking within the range of the support of this function, so from 0 to 1, we have 4x cubed dx. Now to find e of x, so let's just write that down, the mean. So e of x, what we do now is we multiply this function by this x in here. So that becomes now x times 4x cubed dx, and it's integrated from 0 to 1. So let's simplify this up a little bit, bring this down one more line. 4x times x cubed becomes 4x to the 4 dx. Again, parameters don't change. And now we're ready to integrate. So this will now give us x to the 5, which is obviously increasing the power by 1. The 4 is a constant, so that stays. And now we divide by the new power. And that's then calculated along the parameters 0 to 1. Okay, so let's plug in a 1. So if x is 1, x to the 5, that becomes 1 to the power of 5, which is just 1. So that now becomes 4/5. And if x is 0, then this simply becomes 0. So that's minus 0. So then that gives us 4/5. So I'm going to write on here now, our expected value of x is 4/5. So that's our mean. So 4/5, or we can write it as 0.8, or we can also write it as mu. This is an accepted way of writing the mean. Greek letter mu, that is also 4/5 or 0.8. It's exactly the same. Okay, so that's our expected value. So now we need to try and work out the variance. Now we haven't got a lot to go on here. All we've got is our PDF and our mean, which is the same as our mu. So for variance, we've got this formula here which we can use, which is expectation of e to the x squared, which is the second moment, so that's e to the x squared, and then we subtract the mean squared. You could have put e to the x squared. This is not the same. This is e to the x squared. This is the second moment. Mu squared here, don't get this confused with e to the x and then this whole term squared. These two are not the same value. This is the second moment. This is simply the mean, which has now been squared. So this is also, you could probably write this as mu squared. That'd be the better way to write it. This one, you can do it, but it's not really the accepted way. Okay, so we've got our formula for our variance, but we've only got e to the x, which is our mu. So we could calculate mu squared. That's not a problem. So let's just do this down here. Let's just write this. So mu squared. So that's the same as, let's do it gradually here just to make sure we get what's going on. That's the mu squared, so that's the same. And our mu is 4/5 or 0.8. I'm going to choose the fraction. I prefer to work with the fraction. So 4/5, and that is squared. So now we can square the top and the bottom. So then that simply becomes 16/25. So we can write that as a decimal as well if we prefer. So I'm just going to write that here now. 16/25. 16/25 as a fraction, just multiply that top by 4 and then move the decimal place two places. So that's 0.64. So that's our mean squared. So that takes care of that calculation. Now we need to find this e of x squared. Now for the second moment, I've got some videos where we go through some of these moments and how to calculate them. This one is pretty straightforward. We've got the PDF. So what we can do is, same way we calculated the mean, we now look for the expected value of x squared, which is now the integral, as we did before for the expectation of x. So same support, 0 to 1. This time we simply write x squared and the PDF. And then that's 4x cubed, and integrate with respect to x. Okay, first of all I'm going to just clean this up a little bit. 0 to 1, and then 4x cubed, x squared, x to the 5 dx. So that takes care of that. Now I can just integrate this up straight away. So now that's 4x to the 6, and then divide by the new power from 0 to 1. Okay, so now just simplifying off this 4/6, we can just call that 2/3. That's pretty straightforward elementary mathematics there. And now we can calculate this with parameters 1 and 0. So if x is 1, 1 to the power of 6 is just 1, times 2/3, so that gives us 2/3. When x is 0, it just becomes 0. So that just leaves us with 2/3. So now our e to the x squared So our second moment, this equals 2/3. Now I won't write that as a fraction because that's just going to be a 0.6 recurring. Okay, so now we've got that, we can calculate our variance. We've got e to the x squared, which is 2/3, and our mu squared, which is 16 over 25. Okay, now we know that this is going to be a small number because 0.64 and 0.66, there's not much in it. So let's get common denominators on the bottom. So 75 will go here. Multiply this by 25, we'll get 50. So now we've not changed the value, 50 over 75. And then multiply that by 3, so that's minus 48. So that's 2 over 75. So our variance is 2 over 75. So variance is 2 over 75. Now if you want to work your standard deviation from that, then the formula for that is really simple. You could do that from the 2/75. Okay, that completes the question.